Question 3.153. A mixture of calcium carbonate and ammonium carbonate is 61.9% carbonate by mass. Find the mass percent of calcium carbonate in the mixture. Okay, so let's write a little bit of that down. Okay, so we have calcium carbonate. Calcium carbonate. We also have ammonium carbonate. And this whole thing is 61.9% carbon by mass. Carbonate by mass. Okay, what's that mean? 61.9%. So that's like this. Like if you had an 100 gram sample, then 61.9 grams of that 100 grams is carbonate. All right, so let's do something similar to what we were doing with the chapter 2 question, and actually one of the chapter 3 questions. We're going to write out a little system of equations. We're going to substitute a variable in, because we got carbonate in both of these things, so the percent composition of it doesn't help us extricate the calcium species out of this whole mess. So we gotta do a little bit more work here. All right, so first let's make a couple variables here. So let's let x equal moles of the calcium carbonate. So this is going to be the one that we're after. Calcium carbonate. Y is going to equal the moles of ammonium carbonate. There we go. All right, let's write out a couple of expressions here. Okay, so first one is, again, this should look really similar to the other ones. So we know that 61.9% of this carbonate, right? We know that 61.9% of the mass is carbonate, right? We also know that carbonate occurs in each of these compounds, and if you see here, the stoichiometry of the carbonate is the same between each of them, right? 1 mole of calcium carbonate has got 1 mole of carbonate. 1 mole of ammonium carbonate has got 1 mole of carbonate. So that means that these two together, oops, let's not go through the numbers. There we go. X plus Y times the formula weight of carbonate will give us this mass in the 100 gram sample that we were looking at. 61.9 grams. So we're going to take this thing and we're going to rewrite it in molar terms. And then once we have that, we're going to substitute it into a similar expression to the ones that we've been working with already. Right, which is X times the formula weight of calcium is going to be Y times, well, this is actually Y, 2 times the formula weight of ammonium, because there's 2 of those in the mole here, right? 2 of them per mole of carbonate and ammonium carbonate, and this is going to be equal to the remainder from the 100. 38.1 grams. That's coming from 61.9 of 100 grams being carbonate, right? So this 38.1 is just the remainder. Okay, so step 1, let's rewrite this in molar terms first. Okay, so 1 modified. So moles of the carbonate. Carbonate is going to be equal to the mass of carbonate present divided by the formula weight, and that is equal to 61.9 grams divided by 60.01 grams per mole. All right, and that gives us a grand total of 1.0 0.0315 moles of this in total. So this means that this expression we can now write as this. X plus y equals 1.0315, right? And this should look awfully similar to some of those ones that we've been dealing with already. So we're gonna go ahead and solve this for y immediately, and I'm just gonna write it over here, where y equals 1.0315, point there, minus x. All right, now I'll erase this stuff out of the middle here, and then we can stick in that expression. Let's just get rid of these two then. There we go. Okay. So let's write this out. X times moles. Moles, and we'll write the formula weight out. There's calcium. Times y mole, and this is of ammonia, which is 18.02, but we actually need to multiply that by 2 again because of the stoichiometry here. So 2 times 18.042 per mole. And that is equal to 38.1 grams. 0.1 grams. There we go. Okay, so moles cancels out all of these, right? And again, we've got grams common in all of these. So we're going to divide grams out too. We get left 40.08. It's an O. X plus 2 times 8 gives us 36.084. Y equals 38.1. Okay, let's sub out y and solve for x. Alright, so this stays the same. And here we've got 36.084, and I'm going to bring in this here that we arranged earlier, equation 1 in molar terms, 0.315 minus x. All right, still equal to 38.1. Okay, distribute this, collect some like terms. All right, I'm gonna, well, yeah, I'll write it out. Can't hurt. 40.08x plus 37.221 minus 36.084x, again equal to 38.1. Okay, collect our like terms. We get 3.996x equal to 0.879. Right, and solve that by simple division, and x is equal to 0.220. Okay, so we know that we've got that many moles of calcium carbonate in this whole mixture of these two carbonate species. All right, so we're gonna stick that off to the side here. X equals 0.220. And it'll again make us some room. All right, home stretch. Okay, so since we have the moles of the calcium, we can multiply this by the formula weight of calcium carbonate, and we can divide it out of the 100 gram sample that we were Well, actually, you wouldn't even have to do that because we're dividing by 100 and multiplying by 100. But you'll see what I mean by that in a second. So let's go straight for the mass percentage. We're going to do this all in one step. Mass percent of calcium carbonate. Here we go. Equals mass of the calcium carbonate present divided by the total mass. And this thing technically times 100. All right, but this, you'll see what I mean in a second. Okay, mass of this is going to be the moles, 220 moles, times the formula weight of, and now we need the whole carbonate compound, not just the calcium like I used in this, in equation number 2 there. So calcium carbonate is 100.09 grams per mole. All right, and all this over the mass of the total sample, which was 100 grams, and this whole expression multiplied by 100 for the percentage, right? So you see what I mean about the unnecessary hundreds. Okay, moles cancel, the grams cancel, and we get a figure of 22.0% calcium carbonate in the mixture. All right, so hopefully that made some sense. It's sort of a long process. Kind of too bad I can't leave all of it written up on the board at the same time, but that's how it's done.